Hi, sixth graders. Okay, let's open our math notebooks and go to the table of contents. And at the bottom, we should be on lesson 7.1. We're starting module 7, lesson 1. And so under lesson, put 7.1. The title of this lesson is Ratios, Rates, Tables, and Graphs. And the pages in your notebook, I think, should be 31 and 32. Okay, turning to page 31, we need to set up your notebook page for lesson 7.1. So at the top, write 7.1 and then the title, Ratios, Rates, Tables, and Graphs. And then for this lesson, you will just need 3 large boxes. The bottom box should be your biggest. And so if you divide the page about in half, your writing space in about half, and create 3 spaces like this, that should be good. Okay, so for box number 1, this is the information we're going to start with when we're talking about ratios and rates. So the first thing we want to do is define a few terms, and the first one is a unit. And a unit is a single item, so it could be 1 ounce or 1 pound or 1 mile or 1 hour, but it's when you break something down into just a single item of 1. And then a rate is the ratio of 2 quantities that have different units. And so, for example, if you go 60 miles in 2 hours, that is your rate, all right? So I'm comparing, I have miles to hours. So I'm comparing how many miles I go in 2 hours. So when you have a ratio that has 2 different units, like miles and hours, that's called a rate. So my rate is 60 miles for 2 hours. A unit rate is the rate in which the second quantity is 1 unit. So if my rate is 60 miles in 2 hours, I want to find out what my unit rate is. I have to break it down into just 1 hour to get a unit rate. So how many miles will I go per 1 hour? And that's my unit rate. So if I go 60 miles in 2 hours, then I can divide that by the 2 hours by 2 to get 1 hour on the bottom, to get a 1 on the bottom to get a unit rate. And that gives me 30 miles per 1 hour, and that's my unit rate. Okay, in box number 2, we're going to talk about using a table of information to find ratios. And so we're going to create a table that has information about time in hours and distance in miles. So at the top of in the box, you need to write time, and then we're going to do 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. And then for distance in miles, we're going to start with 60 miles per 1 hour. So we're going to write 60 underneath the 1. Okay, one thing we do when we're talking about distance and time is we always put distance over time, because the distance you go depends on the amount of time you travel. And so that's just the standard way that it's given, is distance over time. So if I have distance over time, my distance, according to my first column of my table, is going to be 60 miles per 1 hour. So 60 to 1. And since I have a 1 as my second measurement, then that is my unit rate. So 60 to 1 is my unit rate because it's 60 miles per 1 hour. So if I want to then go and find the rates or the ratios for the other times, I'm going to use that unit rate, and I'm reversing it. It's opposite of how it shows up in the table, just because we do normally do distance over time. So I just flipped it. So if I go 60 miles per 1 hour, I'm going to set that up as a proportion, which means I'm going to have 2 equivalent ratios. So 60 over 1 is going to equal x over 2, because I want to find how far I will go in 2 hours. So the way I do that is I look at the 2 ratios I have, and to create a proportion I have to make equal ratios. So to go from 1 to 2, I multiply by 2. So whatever I do on the bottom, I have to do to the top. So if I multiplied by 2 on the bottom, then I'm going to multiply by 2 on the top. It's kind of hard to see that, but I'm multiplying by 2. So 60 times 2 is 120. So the first one, x is going to equal, and I've kind of not left myself enough room here, is going to equal 120. So I'm going to put that underneath the 2 in my table. For the next one, I'm going to set it up again, distance over time. So 60 miles per 1 hour is going to equal an unknown amount of miles in 3 hours. So again, I use the same system. I go from 1 to 3. I had to multiply by 3. So I'm going to multiply 60 by 3, and that's going to give me 180. So I'm going to put 180 in my chart. Moving on, if my unit rate is 60 to 1 and I set up a proportion with equal ratios, I go from 1 to 4, I have to multiply by 4. So 60 times 4 is 240. And I'm going to have to draw an arrow because I didn't leave myself enough room. So underneath the 4, you're going to put 240. And then the same thing for 5 hours. I set up a proportion with 60 over 1 equals x over 5 because I don't know the distance, I know the hours. And so I set it up with an x as my unknown for the distance. So 1 times 5 gives me 5. So then I multiply 60 times 5, and that gives me 300. So x is going to be 300. So I put 300 underneath the 5. So if you look at the chart, you have, if my ratio is 1 to 60, so 1 hour per 60 miles, and the equivalent ratio would be 2 to 120, or 2 hours to 120 miles, 3 hours to 180 miles, 4 hours to 240 miles, and 5 hours to 300 miles. And so those ratios are all equivalent because they all equal the unit rate of 1 to 60 or 60 to 1 if we flip them over. Okay, in box 3, we're going to talk about graphing information on a coordinate plane. Remember, a plane is just a flat surface in space. And so a coordinate plane is where we use coordinates. We use an x-axis and a y-axis. The x-axis goes across and the y-axis goes up and down. And so what we're going to do is, the first thing we're going to do to graph information on a coordinate plane is we're going to, step 1, create an ordered pair for each ratio. So I'm going to use the ratios that I used in step 2. I'm going to use those same ratios to create my ordered pairs. So one way you can think of it is you say 60 to 1. Another way to write that is with the colons, 60 to 1, like this. And then that kind of helps you to know how to place them on your graph. Because remember, the first number in a coordinate is your x value, and your second number is your y value. So in this case, x is going to be 60 and y is going to be 1 because of the way it's written. If I reverse the fractions, I said 1 to 60, then my x would be 1 and my y would be 60. But we can talk about that later. So either way that you set it up, it's going to be okay. So for 120 to 2, now I'm going to write that with a colon, and you don't have to do that. It just helps you to know which order to put the numbers in your coordinates. So 120 comes first because it's at the top, so 120, comma, and 2 comes second. And again, 120 is my x, 2 is my y. In 180 to 3, I'm going to rewrite it with a colon, 180 to 3, which when I put it in coordinates is 180, comma, 3. Then 240 to 4, I will write it with a colon. And then in coordinates it will be 240, comma, 4. And 300 to 5 is 300, colon, 5, which is in coordinates 300, comma, 5. Now, what the next thing I do is I'm going to take those x and y coordinates and I'm going to graph them on this coordinate plane. And so I set up a coordinate plane based on my coordinates. And if you look at the x coordinates, I have 60, 120, 180, 240, and 300. And so those are all multiples of 60. So I set my coordinate plane up with those multiples of 60 because those are the numbers I'm going to be using. So you can use your coordinates to help you know how to set up your numbers on your coordinate plane. So I have those x coordinates all at the bottom on my x-axis, which goes across. Then for my y-axis, I have my y coordinates, I have y 1, 2, 3, 4, and 5. And so I put those vertically on my y-axis on the graph. So again, this is going to be my y-axis up here vertically, and my x-axis is horizontal. If you can see it over there. I just kind of made a mark there so you could see it. Okay, so I'm going to graph those, and the way I do that is I go across for my x-axis and I go up for my y-axis, and wherever those meet is where I graph or I write my dot. So the first one is 60, 1. So I go across to 60 and up to 1, and the point where they meet is where I graph. So that's 60, 1. Then for the next one, it's 120, 2. So I go across 120 and up 2, and I where those lines intersect is where I graph. The third one is 180, 3. So I go across to 180 and up to 3 and graph it. 240 and 4, I go across 240 and I go up 4 and graph it. And then 300 and then 5, I go across 300 and up to 5. Then, using a ruler or something, I connect from 0 through the coordinate plane all of those dots. If my ratios are equivalent, which in this case they are, my line should look pretty straight, should form a straight line. So any point along that line is going to give you an equivalent ratio. So I can even use decimals and fractions, and we'll talk about that a little bit more in class, but I can graph like 1.5 and I can find the x coordinate. I can graph 2.5, 3.5, basically any decimal or fraction. But if it's an equivalent ratio to 60 to 1, it's going to show up somewhere on that line that I've already drawn. Okay, so when you finish, this is basically similar to how your paper is going to look. I think in box number 2, we may have carried it out. I think we carried it out all the way in the sample. I only did a couple of them. But for the most part, this shows you how it should look. I did add a note underneath the coordinate plane in box number 3 that equivalent ratios will equal a line on the coordinate plane. And you can write that down if you would like. So that's it. We're done. We will do some more work with this in class, and we'll do a little bit more difficult problems so that you can see how they compare and how they make equivalent ratios as well. Okay, good job.